Hey guys, it's Julia. Today I'm going to teach you how to graph rational functions with a 7-step process. This is the function we're looking at first, x minus 1 over x squared minus x minus 6. First step is to simplify the function and find holes. Simplify this. This is what you get, factor numerator and denominator, and this is what you'll get out once you do that. A hole is when you simplify your function and you get a term on top and bottom that is the same. So say I had x minus 1 on the bottom. That would mean that these two terms could cancel and that would be a hole in the graph. But in this case, there are no holes. Moving on. Second step, we need to find the x-intercept. So to do that, you set your function equal to 0. And what I want to do here, algebraically, obviously get rid of the denominator, multiply by the opposite reciprocal, and we get x minus 1 equals 0. Add 1 to both sides. We know our x-intercept is at x equals 1. Moving on, finding the y-intercept. Everyone knows how to do that. I hope so. Set each x value in your function equal to 0. So we have 0 minus 1 over 0 minus 3 times 0 plus 2, which you'll get out is y equals negative 1 over negative 6, which is the same thing as 1, 6, which is our y-intercept for this function. Moving on, we're finding vertical asymptotes. Vertical asymptotes are lines on a graph in which the function is infinitely approaching but never touching. So to find these, you'll take the denominator of your function, set it equal to 0. We have x minus 3 times x plus 2 equals 0. No, there's two values of x that make this true, so take them both out. And we find that x equals 3 and x equals negative 2. Those are our vertical asymptotes. Next, we have horizontal asymptotes. Horizontal asymptotes are basically the same thing as vertical asymptotes, just horizontal. Horizontal lines on the graph in which the function is infinitely approaching but never actually touching. So there are a couple types of ways to find this. If the exponent on the numerator, or the leading term of the numerator, is greater than the exponent on the leading term of the denominator, that means you have a slant asymptote. We'll get to that later. If the exponents are the same, then what you'll do is you'll take out the leading coefficient, take the one on the numerator, take it to the denominator, divide it, and that is your horizontal asymptote for that case. If the exponent on the top is less than the exponent on the bottom, then you'll always have a horizontal asymptote of 0. So in this case, we can see the one x to the first is less than x to the second, so we have a horizontal asymptote of 0. Here's just a little example of how you would find the horizontal asymptote if the exponents were the same. Next step is to graph it. This is my finished graph. I'll tell you how I got there. First step, plot all the points you just found. X-intercepts, y-intercepts, vertical asymptotes, which are dotted lines, horizontal asymptotes, which are also dotted lines. So what we're going to do next is take points on this graph and plug them into your function and find what y value you get to kind of determine where the rest of the function goes. So we're going to start with f of 2. When I do f of 2, I get out a negative 1/4. So that means at x equals 2, y equals negative 1/4. So if we just have this, and we know it can't cross over the horizontal asymptote or the vertical asymptote, we can know that this graph is infinitely approaching but not touching this side of the vertical asymptote. But what's happening over here? Well, let's plug in another point. Let's plug in f of negative 1. So when you do that, you get out a 1/2. So at f of negative 1, y equals 1/2. So we know that if we have these 2 points, can't cross over this horizontal asymptote, can't cross this vertical asymptote. So it's going up and infinitely approaching this vertical asymptote, as well as infinitely approaching this one as well. Now what's happening in these sides, right? Let's plug in some more points. Plug in f of negative 3, for example. If you do that, you'll get out a negative 2/3. F of negative 3 is at a negative 2/3. It's about right there. Now with this point, we can automatically know, well, it's not crossing this asymptote or this one, so we know it has to infinitely be approaching both of those. But to prove that, plug in a negative 4, and we get a value a little less than what we have, negative 2/3, but still not 0. So that just proves the point that it's infinitely approaching this asymptote as well as this one. What's happening over here though, right? Plug in these values. Plug in f of 4 and f of 5. We get out 3/8 and 2/7. As we can see, it's infinitely approaching this horizontal asymptote and this vertical asymptote. Next, we're going to talk about slant asymptotes. What is that? That's basically when you have a function where the exponent in the numerator is greater than the exponent in the denominator, like this one. So we can see 2 is greater than 1. What do we do? Something called polynomial division. So it's basically like long division, as everyone should know what that is and how to do that, except with polynomials. So you take the denominator, put it on the outside, numerator, put it on the inside, and then think about, take the first term of the outside and say, how many times does x go into negative 3x squared? I'd say it goes in negative 3 times, so place it on the top. Then distribute that to the x and the negative 1. So you put those down here, and remember, when you're writing out the function inside, the little term inside, you have to have these placeholder values. So it jumps from x squared to no x, and you need to have an x in the middle as a placeholder. That's very important, remember that. So we have the negative 3x times negative 1 is 3x. It's a subtraction. These cancel. Bring down the 2. Negative 3x plus 2. How many times does x go into negative 3x? Negative 3 times. Place that up top. Distribute. Negative 3x plus 3. Subtract it. We're left with a remainder of negative 1. That's not important. What's important is what we found here, because that is our slant asymptote. Slant asymptote is at y equals negative 3x minus 3. But how do we graph it? Well, let's figure that out. So, as you can see, do the same thing as I did. Complete all the steps I just taught you. So x-intercepts, y-intercepts, vertical asymptote, and slant asymptote. This is our linear function of the slant asymptote in yellow. We already have these 3 points, and we know that it's infinitely approaching this line as it goes upwards, and infinitely approaching this line as it goes upwards. And it can't cross here. Can't be going down and then up. Can't be going through. Can't be going anywhere else except right here, because these are our parameters. And it kind of just gives you a little triangle shape for you to know where it's going. But what's going on over here, over here, over here? Well, let's plug in another point. F of 2, we get out a negative 10. So we have a point down here. And that's within these parameters. So we know that this half of the graph, or this half of the line, is infinitely approaching this vertical asymptote, as this line is infinitely approaching the slant asymptote. Can't cross through either of them. So it gives us, again, a little triangle to figure out where the graph is going. Thank you guys for watching. Hope you learned.